Hi, I'm Nathan Evans. I'm going to be going over the ZeroCap zero-shot image-to-text generation for Visual-Semantic Arithmetic. This comes from the people over at Tel Aviv, Yao Tul, Yov Shalev, Edon Schwartz, Lior Wolf, and they're again from Tel Aviv University. So here I'm just going to be going over the overview of the zero-shot algorithm, examples, and an explanation. So zero-shot basically means that it's capable of performing a certain task without actually having any prior training. So that's hence what this is. So it uses a clip, and I'll explain more of this in the later slides, which is an image-to-text transform model. It's capable of performing many downstream tasks without any extra training, and it accomplishes this by choosing a sentence that is the best match to a description of a given image. So they use the clip along with ChatGPT-2 to form a text description of the image that is inputted to it. It does not involve any training, hence the zero shot in the title. And there are some other types of text generation, mainly the supervised captioning method, and this does produce human-like response, but this model has much more freedom than these other supervised captioning methods. So we'll just get right in. This is just a quick example. I have some more detailed ones later. This is just a car on a road in the picture, but whenever you pass through, it gives car driving on road. So here's some more examples. You can also do arithmetic or comparing two images. So right here we have, looking at the top row, we have a woman added with a king minus a man. So this will give you a young queen, or just queen. And at the bottom we have a cow plus egg minus chicken, and this will give you a cow's milk because that's what they produce. So moving on to visual captioning. Visual captioning is when you create a sentence that describes an image. So in this research paper, they generally start all their phrases with image of A, as you can see in the little diagram we have here. And then next they use a loss, which is called clip, which helps generate the sentence that fits a certain image. And clip basically judges how close a word is to what the image actually is. Another loss that's used is LCE, which you can see in the diagram in the middle. This makes sure that the next word that is used is actually related to the image. So here we can see we have image of A, and then the LCE is deciding whether the next word, if man is more related to the picture, or if ego is more related. Not only does it measure the clip loss, so some of the other metrics, whenever we look at comparing other visual captioning tools, we have BLEU, Meteor, Solder, Spice, and clip score reference. This method lags in some of these metrics, but it does have its advantages when it comes to vocabulary size. So this tool's vocabulary is significantly larger, and with this larger vocabulary also means that each sentence is 100% or near 100% novelty, which just means that the captionings that it's actually coming up with are very unique compared to just very cookie cutter captions that were previously used. Now it doesn't lag in clip score, which this metric measures the actual relatedness between the image and the sentence that is produced. So this just takes whatever the output sentence is, and just tries to compare it back to the image and comes up with a score that way. And that just helps this method become significantly better than previous methods for visual captioning. Alright, so now I'm going to go over an example. So this one is directly from the research paper. So this is just going to be some image arithmetic. So it's going to take in two images, then it's going to use clip to get a description of each image, just like we talked about before. And so we can see for the images right here, we have Barack Obama and then the USA flag. So it's actually coming up, it's using clip, getting the loss, and then deciding what the actual caption should be for this. Then you can perform arithmetic. So you can add or subtract images to get a new phrase, which is the answer to whatever the equation. So going into this example, we have the picture of Obama on the left and America's flag. Then if you say subtract America's flag from Obama, then it's going to give president as the actual output. So you can actually add the code word for the flag of another country to this result, like Germany, for example, and it would then say it would then generate who is the president of Germany from this. You can also use it with words and images combined, which is interesting because then you can take, say, Obama, and then instead of just a picture of America's flag, you could actually just write American flag or America's flag, and then you will still reach the same output even after using this the images and words interchangeably. Alright, so now I'm just going to be going over some examples, and then I'll talk about some of the testing later. So we can just read through some of these real quickly. I'll just scan through them all to discuss them, and then we have a couple more on the future slides. So here we have, I'll just read through the clip VL and then their model for all of them. So toilet sitting on a ledge in a bathroom, and then a new rooftop toilet being installed on a residential street. So here you can see that that novelty showing through. With the first one, you have just a toilet sitting on a ledge in a bathroom. But then with this new model that they have, it's very unique in all of its descriptions. We can see that in the future here. So a boat with a picture on it in the water, a boat with a message on the side saying token, a tray of food on a table with bread and drinks, a flight meal being served on the Boeing 707 aircraft, a bathroom with a sink and a mirror, a bar restroom with portraits of the late 19th and 20th century, a bird sitting on top of a window, a red falcon in the exhibit, a bathroom with a sink and a mirror, a bathroom with a mesh tile pattern, a group of people standing in the snow with skis, winter activities of parents with children, a mirror on the wall in a bedroom with a bedroom with posters on the wall that show bands. So yeah, you can see that there's definitely way more uniqueness than the other previous visual captioning tools. So now we're going to take a look in the arithmetic. So I'll just go through a couple of them because there's a lot on here. So starting off with the top left, you have a caricature illustration of a plane, and then you have a plane. So whenever you go to subtract these, you just get a character illustration. Then the next one, you have a bunch of basketballs, and then you have a basketball. So then whenever you subtract these, you just get a bunch. And you can just go through these, and we'll talk about how it's actually coming up with some of these whenever we talk about the tests. So here's some more arithmetic. This is actually leading into the next slide for relatedness. So if we have the Germany flag and then you add that to the Obama minus American flag, then you get Angela Merkel. And then looking over at the CEOs, you have Mark Zuckerberg added with Microsoft minus Bill Gates, and then you get Facebook. And it can even do it with food, not just people, or places and buildings. So whenever we're looking at this, it uses a benchmark called visual relations, which is short for VR, or VR is short for visual relations. And this is just assesses the relation capabilities of the technique. So what they use is it consists of 320 relations with templates, which use it combines buildings with countries. So any buildings that are unique to a certain country, it has those leaders, foods, CEOs, etc. Anything you can imagine. So it aims to measure the ability to visually model relations and just apply the real world knowledge. So here we have sushi, which is Japan, and then if you look at pizza, then it would say Italy, and that's just the that's like one of the 320 relations that is shown here. And here are just my sources. So, yeah, thank you.